Good morning or good afternoon or whatever it is in your part of the world. Today we're going to be reviewing the hydraulic design for a 200-acre pecan grove in the great peach state of Georgia. Now, the net acreage is going to be approximately 200. That excludes the roads, the ditches, and all the out areas. This project was designed with 2 pumping stations, each delivering about 420 gallons per minute. The application rate on this particular system is 12 gallons per minute per acre. Now, when we look at the legend on this hydraulic design, we'll see an icon for a flush valve, and it's a red triangle. Growers will decide just how many flush valves they want to install. Everybody has to install at least one flush on the manifold, which is the end of the low volume irrigation system. But many farmers will decide to do a flush at the main line to submain connection and also at the submain to manifold connection. Now, why do we use flush valves? Well, like I said earlier, flush valves can be installed at the end of each PVC main, at the PVC submain, and the PVC manifold. But all of them are installed to flush debris that's collected during the installation and debris that is collected during the normal operation. The size of the flush valve is dictated by the amount and the size of the debris that has to be flushed and cost efficiency. So typically flush valves on PVC manifolds are 2-inch and they can be manually or automatically actuated. Automatically actuated flush valves can be controlled by electric wires, hydraulic tubing, or radio telemetry. Both the manually operated and the automatically operated flush valves are installed above ground. I have a set of drawings that we're going to reference in a minute, but it shows above ground manually operated flush valves. The manifold that's constructed will be identical whether the flush valve is manual or automatic. And occasionally, because of change in elevation, the flush manifold may require a continuous acting air vent. So these are the components that make up the flush manifold. Now this section of pipe can be 3 feet long, 4 feet long, but generally speaking, we'll set this manifold up to be about 2 feet above ground level. Then we'll have a short, approximately 6 inches of pipe, and then a 45. Remember, the 45 directs the flush water away from the crop so we don't destroy any plants. Over my right shoulder, we have a valve manifold that we've constructed. You can see the water's directed to a 6-inch T. We have a 6x4 and a 4x2 slip by thread reducing bushing and a 2-inch continuous acting air vent. Then the water's directed through the hydraulic valve. That valve is controlled with a wire, with hydraulic tubing, or radio telemetry. The water's then directed to a 6-inch 90 and back into the manifold or submain. It is required to have a 2-inch continuous acting air vent on the upstream side of your valve manifold. This particular farmer opted not to have flushes at either the main to submain connection or the submain to manifold connection. He only wanted us to install flushes at the manifold connection or the end of the line. That icon is a red triangle, and you can see it. I'll highlight a number of these. You can see the pecan grove is irregular. Rows run in every direction. And at the end of every single manifold, you're going to find a red triangle or a flush valve. Finally, this is the typical drawing for the flush valve at the end of the manifold or the PVC manifold line. Generally, we finish with 3-inch pipe. We can also finish the manifold with 2-inch pipe. If it's 3-inch pipe, we'll have a 3x2 slip reducing bushing, and we'll install a 2-inch B valve or banjo style valve for our flush. We'll also put a 2-inch 45 to direct the flush water away from the crop. This typical shows the last reducing T on the manifold line, and then right behind it, the flush manifold valve. I think we spent enough time going over drawings and hydraulic designs. We need to get to the best part. grab your boots. We're heading to the field. Well, we're at the end of the line. The water has passed through the PVC main, through the sub-main, entered the manifold, and we're all the way at the very end of the manifold line. Now, what you'll see is the rigid PVC pipe that comes up, and what you have here is the connection between either flexible or rigid PVC and polyethylene. Polyethylene is the point where we enter the above ground section of the low volume irrigation system, and now we're moving horizontally in the tree row. And you've seen this in a previous video, but now we'll apply an emitter at the base of every tree for water. Every manifold ends the same way, with a flush. And we have to have a flush valve on the end to get rid of debris. Most of the debris is acquired in the initial installation, but there is debris that builds over time. In a previous video, you saw the primary filtration, and then that water goes into a secondary filter. But even with all those efforts, there's still a lot of garbage that gets in. And this valve allows you to flush the manifold line and keep the emitters clean. So you can reach us over the telephone at 772-468-0888 or on the web at asi.ag. Hope we're helpful, and thank you for allowing me to do what I love to do. Talk to you soon.